Recommendation systems are everywhere. From TikTok to YouTube to Amazon and to even Airbnb. But oftentimes they can feel a lot like magic. Well, in this video, I'll show you exactly how these algorithms work with just simple and intuitive math. And we'll be going over 6 recommendation systems. So let's get started. First, memory-based collaborative filtering. Imagine you own a small restaurant and start recording your customers' orders. And this is what you get. Bill has recently tried the combination of the shawarma and the milkshake. You see that in the past, Ben has ordered the same dishes as Bill, and so you decide to recommend the shawarma and milkshake to Ben. That's all it is. Similar clients get similar suggestions. 2. Matrix factorization. You now want to explore exactly how and why people like dishes. For example, some customers like spicy and low-calorie foods. Others like meaty and very heavy foods. Well, first, meet Ahmed. He likes shawarma and milkshakes. And spicy food. And maybe drives a BMW. We want to predict what else he likes. We first create a matrix of each food, like this, where spiciness goes from 0 to 1 and sweetness also from 0 to 1. We can then plot each dish, and this is how it would look like. We then morph Ahmed into a vector based on his previous purchases. So this is Ahmed, he likes shawarma and milkshake, and this is the vector that he gets. And then we plot him also. Now we can see which items are closest. Since shawarma and burger are the closest, we recommend him these again. But how are these vectors found? First, we create random numbers for each dish and user. And then we check how similar these numbers are using the dot product. It is basically just a technique to see how close two vectors are to each other. For example, for Ahmed and shawarma, he would get 0.51 by calculating the dot product. This means that there is a 51% chance to recommend Ahmed a shawarma. However, we know that Ahmed liked shawarmas in the past. So the true value of Ahmed and shawarma is 1. Since he definitely liked it in the past. But we predicted only 51%, which means there is a high error. And similarly, we go over these with all of his previous purchases or not purchases and see if we predicted it right or not. As we can see, he never ate a burger, and we predicted that he had a 42% chance of liking a burger, which is also a very high error. And so we gradually fix this using a process called gradient descent until the model can predict it accurately. And you can learn about gradient descent from this video from StatQuest. Next, neural collaborative filtering. This builds on top of the matrix factorization and is very similar to it too. It uses a neural network to learn the hidden features of the users and dishes. If you're not familiar with neural networks, watch this also from StatQuest and skip this part. The neural network we use for this is a multi-layer perceptron. We first combine the Ahmed and shawarma vectors. Then we connect it with 2 fully connected hidden layers. And then get the output between -1 and 1. The rest is just the same as matrix factorization. Next, content-based filtering. Imagine you have a table with all your dishes and some attributes. As we can see, here are the calories for each dish, and whether it's vegan or not vegan, and whether it's spicy, not spicy, or mild. Ahmed is new to your restaurant and wants something vegan and not spicy with about 500 calories. And so his preference is a vector of 500 calories, vegan, and spicy. Then we compare his preference to the other dishes and find that fries would be the best recommendation for him. Using math, we would convert everything to numbers and put them into a vector. Calories is already a number, we don't have to do anything there. Vegan can either be 1, or if it's not vegan, it will be 0. And spicy can be 1, and not spicy can be 0. And so Ahmed's search would be 500, 1, and 0. This we would then compare using something called cosine similarity with all dishes. This just basically tries to measure how close two vectors are to each other. The output would be between 1 and minus 1, with 1 being very similar and minus 1 being totally different. Next, sequential models. Imagine you start tracking the sequence customers buy orders. For instance, Bill first buys a shawarma, and then a fries, and then milkshake, and then a drink. And similarly, Bob first buys a shawarma, then fries, then a burger, and then a drink. Ahmed is about to finish his first order and starts off with shawarma and fries, as we can see here. You see that most customers who buy shawarma and fries then also right after buy soda. And so you recommend Ahmed to also buy a soda. Lastly, graph-based models. Instead of looking at users and items separately, graph models treat the entire system as a network of users and items connected by interactions. Every user and every item is a node. Every purchase is a connection or an edge between them. Then we spread signals across this graph to recommend new items. Like this. This is great for finding community tastes. And that's it. 6 very common recommender systems clearly explained. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.